overview plans of the works. The fleet we were having here in Peru the last 2 years were 2 hopper dredgers, one big hopper dredger of 11,000 cubic meters, one small one of a little bit more of 3,000 cubic meters, a backhoe dredger for dredging the hard material, and a barge to work together with the backhoe dredger. Of course, apart from all the high technical vessels to work with optimal productions, the environmental part is becoming more and more a very important part in the dredging. Some techniques we can use with dredging vessels to control the environmental aspect is, for example, turbidity valves, green pipe system, and with the stationary dredges, low turbidity dredge heads. In the following slides we will explain a little bit what this is. Actually, there's 4 different ways of dredging. The first way is to dredge without overflow, meaning that you just enter your material in your hopper. Once the hopper is full, you bring the material to the dump. The second way is to dredge with overflow, which means that you load the material into the hopper. Once you reach the maximum level of the hopper, you keep on loading and material is going out via the overflow. A third way is with overflowing, but with a low turbidity valve in the overflow funnel. And the fourth way is dredging with a green pipe system. In the following picture you can see the overflow. So as you can see, this is inside the hopper. Once the material reaches over there, it goes into the overflow. Now, what is a low turbidity valve? In the following slides, it's a little bit illustrated. It's an adjustable valve in the overflow that chokes the flow in such a way that no air is taken down with the suspension leaving the hopper. As no air is coming out of the overflow, or at least reduced, the turbidity under the hopper is minimized in a very big way. The second system, the green pipe system, works as following. The overflow suspension is pumped through an additional pipe which is mounted on the dredging pipe, and afterwards it's pumped back to the suction head where it's used as process water and pumped back into the hopper. So in the following slides you can see how exactly that works. So in first instance the hopper is filled, it will overflow, the water and material, the fine material comes in the overflow. It's pumped again to the suction head, where it enters again in the suction head, from where it can go again into the hopper, and in such a way you can keep on loading, and this in an environmental, very responsible way, because you don't have any turbidity under the vessel. Another time, the 4 different techniques we are using to control the whole environmental turbidity problem. In the following slides we show a little bit the difference of the impact of the 4 different ways of controlling the turbidity. In the first slide you can see, if you just start in the normal way to load the hopper, at the suction head, left on the bottom of the sea, you see a turbidity plume. The more you dredge, the bigger this plume becomes normally if you don't control it. Once you reach the overflow, as well under the vessel, you get quite a turbidity plume. If you continue loading like that, really you're environmentally polluting quite the port. In case you are working with a low turbidity valve, you see the impact is much less because you don't put any air into the water. And then in the fourth system with the green pipe, you can see that you are avoiding completely the turbidity under the vessel and that you just stay with a little bit of turbidity at the suction head. And actually this is the way we do prefer to dredge. Just a little overview to see the differences if you are dredging in an environmental responsible way or you just dredge for the maximum production. It's a very big difference. And of course we are dredging mostly where necessary with the green pipe. In the overview you can see a little bit in figures the impact of the different systems. If you are dredging with a low turbidity valve, you reach a level of 41% compared to the level that you are not using any special techniques. With the green pipe, you only have 21% of the turbidity. And of course, if you dredge without overflow at all, you have almost no turbidity. Apart from the controlling of the turbidity, in every dredging project, we are measuring the air quality in the dredging zones continuously. We are taking water samples around the vessel, which we are analyzing immediately to take actions if necessary. We are monitoring sound pollution in dredging zones. Of course, the normal waste handling, but this is a very important part also with vessels. And of course, all procedures are always in place, oil spill prevention in ports. Another important way for dredging environmental responsible is the location of the dump. One has to find a compromise to put in one way the dump as close as possible for dredging with a maximum production, but on the other hand, the distance has to be large enough to keep any influences to the beaches, to the port, as less as possible. In the part of Callao, our dump areas were until 12 kilometers, which was definitely far enough. A couple of weeks ago, we finished the project, the Obras Comunes here in Callao. We finished this with placing the navigation aids. But at this moment, the vessels have gone from Peru, but we hope very soon to be here again in Callao for future projects. Thanks a lot.
Nuestro agradecimiento a Tom y a Jan por la exposición y